Alright, welcome to Chapter 6, Section 3, Dividing Polynomials. We're going to actually divide this into two parts. So the first part is just going to be using long division to divide polynomials. Then I'll do another one that will be a second part using synthetic division to divide polynomials and evaluate polynomials. So that one's a little bit different, but this one, the dividing using long division, I think takes a little bit more practice and should be separated, so that's why we're doing that today. Okay, so what we want to do here, think long division like the way you did in, say, elementary school or even middle school. Okay, so look, we have this problem right here, 12 divided by 277. Well, how do we do that? Well, we say 12 goes into 27 about 2 times. Really because we're saying the 1 goes into the 2 about 2 times. If you think about that. So we put the 2 right there over the 7, and then we say 2 times 12 is 24, and then we subtract, and see that's a positive 24. So actually we're going to make that a minus, change the sign, let's do that again, change the sign, and then divide by 24, or subtract, sorry. 27 minus 24 is 3. Bring down the 7, and then I go, okay, 12 goes and divides into 37 3 times, or 12 times 3 would give me something close to 37. So I get a 36. Then I would subtract to get 1. Okay, that would be my remainder, and technically I could write that as 23 and 1/12. So I put the remainder over the divisor. Long division is similar, and the more you practice with it, the easier it gets. I'm actually going to walk you through 3 examples. So my first example is this: x plus 2 divides into 2x squared plus 7x plus 7. What you need to do here is, on this one, you need to look at the x and look at the x squared. Okay, and think about the 1 here. Okay, the 2 that's in here divided by 1 means I need to write a 2. X times what will give me an x squared? Well, if you're not sure, keep in mind that this has an exponent of 1, and I can say here's that exponent of 2. Division means subtraction, so 2 minus 1, it means I would have 1x. So x to the first power. Now if I take that divisor, or that number, 2x, I need to multiply it to the x plus 2 to get 2x squared. These two numbers, the first two, should always match because they will always cancel out. Plus 4x. 2x times 2 is 4x. 2 times 2 is 4. X times nothing is x. Okay, change the sign, because these right now look as positive, but you're going to subtract. So we're going to change the sign. That would be the key here. This next step, whatever signs you have here, change the signs, then combine. So I'm going to change those to minus. The 2x squareds cancel each other out. 7 minus 4 is 3x. Bring down the 7. Notice I'm putting plus 7. And then, okay, how many times 3 divided by 1 is 3? And then the x to the first, subtract the x, means I don't have any x left, so I don't have to put an x up there. Notice there's a pattern that it should go, whatever your highest one that you have on top, it'll start working its way down. Okay, so 3 times x is 3x. 3 times 2 is 6. Change the sign. 7 minus 6 is 1. That is my remainder, and I can write that as 2x plus 3 plus 1 over x plus 2, the number I was dividing by, or the polynomial I was divided by. Okay, that's how you work that problem. Okay, I'm going to go through a couple more examples and keep trying to explain it like that. But if you need to, rewind, go back and listen. Okay, so here I'm writing out like a problem in standard way. 4x squared plus 3x cubed plus 10 divided by x minus 2. Then I'm going to rewrite it into long division form, but I'm going to make sure I put the dividend in standard form. And also notice here I had to add a 0x. I had an x cubed, an x squared, no x, and then a 10. So if there's anything missing, you have to put a 0 in its place. So 0x. That becomes very important. So now I look. I've got a 1 again. 3 divided by 1 is 3. X cubed divided by an x would give me an x squared. So I should be starting right there. 3x squared times x would give me 3x cubed. 3x squared times a negative 2 would give me minus 6x squared. And then again, change the signs so that positive 3x cubed on the bottom will become negative, but the minus 6x squared will become plus. So then I have 10x squared, bring down the 0x, and then I'm going to say, okay, well, 10 divided by 1 means I should write a 10, positive 10. X squared divided by an x would give me an x. So that way, remember, this number here, this 10x, when multiplied to the x minus 2 should give me that 10x squared, so they can cancel out. That first term should always match. 10 times the negative 2 is negative 20x. Change your signs. So now I have 20x, bring down the 10. Okay, 20 divided by 1 is 20. The x's cancel each other out, so I don't need an x up on top. Multiply. Change your signs. And 50 ends up being my remainder, which I can write as plus 50 over x minus 2. And yes, you do need to write your remainder there at the end. That's part of what you have to do. Okay, final example. 15x squared plus 8x minus 12 divided by 3x plus 1. Okay, so this time you notice I put a 3, or a number in front of the x, not to try to make it more difficult, but to kind of still just have you doing some work. Okay, so I look at this again. 15 divided by 3. Okay. So 15 divided by 3 is going to be 5. X squared divided by an x would be just an x. Okay, and the reason why, again, this number times the 3x should match the number that you see there, that 15x squared, that first number. Okay, so 5x times 3x is 15x squared. 5x times 1 is 5x, positive 5x. Okay, then change the sign so I can combine or subtract, however you want to think of it. So negative and negative. 8 minus 5, because the x squareds canceled each other out. 8 minus 5 is 3x minus 12. Okay, 3x times 1, or 3x divided by 3x is just 1. So then I go ahead and multiply 1 times those, which is just 3x plus 1. Change the signs, and I get a remainder of negative 13. So then I could write that as 5x plus 1 minus 13 over 3x plus 1. Or you could even write that as 5x plus 1 plus negative 13 over 3x plus 1. Okay. That is long division. You will have several practice problems with it. I wanted to make sure y'all could get a concentration on that to where y'all could be able to practice that without too much disturbance or make it kind of easier. Okay. If you do have any questions, feel free to ask during class time or even send me a question through Edmodo. Thank you very much.